So welcome to the William Shockley Test Center, which we rededicated the name of our lab this year to the William Shockley Test Center. William Shockley is the inventor of the transistor effect, so essentially the father of microelectronics. So couldn't think of anybody better to name the lab after this year. But how we've laid the lab out is very consistent with the AS6081 protocol. We start with external visual inspection, and that goes through engineering review. So any defects that we find in visual inspection that already tell us the part is substandard or unacceptable, engineering will stop it there, and we don't need to go through advanced processes. And then advanced inspection processes like destructive testing is done outside of the EPA. X-ray, XRF, the radiographic processes are done at the back of the lab after they pass through engineering. And then only if they even get that far, we'll go through electrical testing, which is the back half of the lab. So our process flow really is to receive, go through visual inspection, engineering review and approval, electrical testing, and then through to packaging and ship out.
So I know you've explained to me before that you guys create a custom software system called Pegasus.
Yes.
Explain to us how that works of tracking from the incoming all the way through inspection test protocol.
Not just every order, but every item number. So if we have an order for 5 different part numbers, every part number when they received are assigned a unique work order number. The carton boxes, when they come in, they are tagged. So we generate a label. That label is identified with the work order number for each one of the carton boxes. The carriers that we remove from that carton box are then all individually labeled with the same work order number. When we take the samples out of the carriers, they're placed in individual holding trays, each, again, with the work order number, so that we don't even mix the samples from between 1 or 2 different reels. Okay. So that's all tracked throughout the system by work order number tracking. The system itself was all internally developed. We looked at some commercial off-the-shelf systems, but nothing matches what we do. So we've developed that all internally. It's all been hand-coded by our IT development team. But that system is everything from our checklist. Our inspection checklist entries are done automatically, or not automatically, but directly into the system from the lab technicians. The photos that they take and all that information is fed directly into the system. And they use in visual inspection, for example, you can see we use 2 different screens.
Correct.
One screen is for the checklist entries, and the other screen is for analysis. They're looking up data sheets, comparing to the package outline drawing, and of course examining the photos, which are going to be fed into the report, which we got to go take a look at that one, because that's really ugly.
All right, so come along and check out this. So what's going on here? Explain to us what's happening. That looks like there's a burn-in or something happened, failure.
First of all, this is a module. This is a completed PCBA. So this isn't just a component inspection. This is a PCBA inspection, which is some stuff that people don't know that we actually do. I'm hoping this is associated with a failure analysis, because if this is new product coming in, someone's got a serious problem already. But this is obviously a shorted out device. So one of the devices, and particularly coming from one lead, is already shorted out on the entire module. So in a failure analysis, we're going to have to break down the device to see where that short actually occurred. Was it a failure on this particular device? Did the failure originate from this device? Or did it originate from somewhere else and it just magnified or became evident when it passed through to this device and passed through shorted out as it went through? But it's a pretty good example at random of why we inspect stuff.